Welcome to the Aero Makerspace 3D Scanner training. The 3D scanner is a great tool for scanning different objects to be used in 3D printing, game design, and animations. This video tutorial will be a quick video tutorial on how to get started with the 3D scanner. The best way to learn how to use the 3D scanner in all its settings is to keep scanning different objects so you can figure out what settings work good and what objects scan the best. So, at the end of this video, you should be able to scan your first couple objects, but the more you play around with the scanner, the more you'll learn. So the things we'll need in this box, we'll need the turntable, its dotted sheet, and the power supply. Then in this box, all of the 3D scanner stuff will be in this very nice case. Make sure to put things back. And finally, on your computer, you will need the software RevoScan. So make sure to have a computer with the RevoScan software downloaded. The AMS computers have this software, but they are not very portable computers, so having it on your laptop is ideal. Here's a quick overview of what's in the 3D scanner bag. So first, we have the 3D scanner itself. This is the RevoPoint Pop 3. We have a test model. This is what we're going to be scanning today. We have a small turntable. We don't really use this because we have the big one. And we have the stand for the Pop 3. The other relevant thing we'll need is the USB-C cable. You don't want to just use any USB-C cable. This is a high data cable that you really want to use, so make sure you use this one. Also, there is a phone holder and a phone power bank, so you can scan by using your phone and Wi-Fi. However, scanning with USB in your computer is the best because your computer is faster than your iPhone, and you can transfer more data with a USB-C cable. So, with that being said, let's grab all our 3D scanning objects. One thing you need to know about the 3D scanner is that the 3D scanner can only scan objects that are not black and not shiny. So they need to be matte objects like this. Other great objects, for example, would be the wood over there. But however, black objects will not scan into the 3D scanner due to the way it measures distance. So if you have a black object, you need to use a 3D scanner spray. This is a spray that basically turns your object white. This is a great spray that basically evaporates away. We're still getting one for the Aero Makerspace, but you need to spray your object with that beforehand. Now, if you want to scan someone with black hair, for example, what you're going to do is they need to put basically baby powder in their hair. This will make their hair not black and allow you to scan people. However, with people, you will need to make sure that they do not move during the scan. So inanimate objects like this guy are much easier to scan. For this training specifically, you're going to want to have these objects ready. You'll have your turntable, which will be plugged in. You'll have the dotted plate on top of it with the guy. And then here we'll have our tripod. You'll connect the Pop 3 to the tripod, and then you'll run the USB-C cable to your computer. So after you have this set up, you're now ready to scan. Here's how this setup is going to work. We have our Pop 3 scanner here. It has a bunch of different cameras and also a distance sensor, so it can basically take a lot of different point clouds and basically make a bunch of points that can comprise your object. How we're going to get the entire object is this turntable is actually going to rotate. As it rotates, we can use the computer's computational capabilities to basically align each rotation and form your 3D model. Now that may sound super complicated, but that's all done in the software. So all you really have to do is a couple button clicks. So we're going to see that later. Down here in our turntable, once it's plugged in, you'll see the glowing dot. There's a middle button that can start the rotation. And then you also can tilt the turntable degrees by clicking these buttons. However, for this training, you actually won't have to mess with any of these buttons. So just leave it like that and make sure it's nice and level. Then for the scanner, it's going to be pointing at the object, but I'll show you how to point it in our software step. Just make sure that the camera lenses are very clean because it needs to get high fidelity scanning of the object. So make sure you don't put your thumb on there. And if you do, make sure to grab a microfiber cloth and clean the lens. So after you have this set up, it's time to jump into the software. Okay, so now we're in the software and we should be connected. So in order to create a new project, I'm going to click here. So yeah. Now you can see we're getting our depth information and all the information from the 3D scanner through that USB. So if you zoom in, you can see that this model is actually made up all the points that the 3D scanner is detecting right now. So you can see that, hey, okay, we got somewhere. We are now looking at our 3D scan. On the top left, you can see that here we have a depth camera, which is useful for seeing how deep objects are, just like the rangefinder. And then on the bottom, you can see the RGB camera. This is to actually get colors into your 3D model. So colors are super important because, if you want to scan something and get colors, you're going to have to make sure that the colors are showing up as in real life. So now that we have our cameras, you're going to notice there's a little crosshair in the middle of the camera here. So you want to aim that crosshair towards the center of your target. So there we go. Now on the right, notice how there is this graph. This graph represents the distance of every single point on this 3D scan. So you can see that farther points get marked as too far, while closer points are excellent. So if I move the 3D scanner back, we're going to move all the points back. But I want to get everything where excellent is, or between excellent and good. I find that for small objects like this, between excellent and good is how you can get really good scans. So we're going to move it so that we can get excellent and good. Also take note that in the right, I need to make sure that the guy is in the field of view and that the crosshair is in the middle of the guy. That way when the guy starts rotating, we should be able to get a good scan of him. So now that we've set up where our 3D scanner should be, you can move the tripod around, you can raise the tripod up, do all that sort of stuff. We can now look into our scan settings. So this is the tab on the right here. First off, we can start the scan like this. This will start the scanner. But obviously you want to set up all the settings first. So we're not going to click start yet. First, let's look at accuracy. Normally running at high accuracy is the best. However, you can try high speed and standard if you want to try, rapid scanning. Tracking mode is the most important. Like I said, this guy is going to rotate, and how the 3D scanner and your computer reconstruct the scan is either up to feature tracking or marker tracking. So feature tracking is where you look at the geometry of an object, and as the geometry changes, you match the scan to basically create a full model. However, marker tracking is different. Marker tracking is where you look at these retroreflective or super shiny dots. Here, I got my finger there, trying to point at them. That is very useful for this turntable because those dots are guaranteed not to move. So whenever you use a turntable with this retroreflective sheet, you want to switch it to marker tracking. What you're going to notice is that the markers will show up in red. However, so you can see right now that the markers are red, so that's good. Object type, general object's the only option, so that's fine. And then color scanning. I would always turn on color scanning because it doesn't actually change how the scanner really scans because the depth is still the same, but it means that it collects images from the camera as well. Right now what's going on is the flash is on, which means that you have a more uniform scan. What that means is that, think about an object. If you put an object under a light, there's going to be shadow. So if you scan that object, you're going to see shadows in your scan as well. If you turn off the flash, you get more realistic shadows in your image. However, if you turn on the scan, you get a more uniform color throughout your scan. So I think the best way to do it for color scans is actually to turn the flash off. Turning the flash off just makes it easier and also gets you more realistic colors. So if you ever want to full color 3D print your models, assuming you have access to that printer, which the AMS does, then you want to turn that scan off because you want to make it look just like real life. Base removal, I don't really use this, but you can notice that there's little tooltips that tell you, it can remove tables that are under the object. So that's pretty useful if you're scanning something on a table, but if you're using the turntable, you don't really have to worry about it. And then the scanning distance, this is super important because you can see that in the back, it's actually scanning this box. So the easiest solution is to move the box out of the camera, just like that. However, sometimes, there might be objects that you can't remove. So what you're going to do is you're going to adjust the scanning distance. This is basically a slider that adjusts how the distance of points that are allowed to be scanned by the scanner. So by decreasing that, I have removed the box from the scan, which is good. So that's one way to do it. However, you can also extend it and then just remove the box. So it's up to you. Now, here is an important part. We're not going to use any of the buttons on the turntable. We're going to use the accessories tab here because the turntable has its own Wi-Fi. So to connect. Alright, so now it showed up. I was on airplane mode, but we fixed that. So yeah, make sure you have Bluetooth on, and now you can connect to the table using Bluetooth. So there we go, we're connected. we can actually adjust the settings here. So you can adjust the rotation speed. Slower rotation speeds will get you better detail, but there's a limit. And also, if you're waiting 1 minute per rotation, then it's going to take a while to scan. So in the interest of this training, we're going to speed it up to 40 seconds per rotation. And we're going to keep the angle at 0 degrees. So yeah, now that we have that, we can start the rotation at 40 seconds for one rotation. You can see that the guy is showing up, the point clouds are being generated, but we're kind of missing a little bit off the top of his head. So we're gonna move it just a little bit back, and then raise the scanner a little bit, so that we can try to fit him in the entire object, or in the entire scan view. If you can't do this, then what you're gonna do is you're gonna move it closer, and then you're gonna scan, and then move it downwards, and then scan again. So you're gonna cover multiple angles. But for this guy, we're just gonna scan here, and I'm gonna see how it goes. So I have it set like this. I have all of him in frame. Most of the points are between excellent and good, which is perfect. My markers are being tracked. There's nothing in the background. So once that checklist is done, you're ready to scan. So to scan, simply click start. So now it's going to start scanning and using the markers to relate all the scans together. So as you can see, it's developing our model. Now if something ever happens, you can cancel the scan or you can pause the scan. Pausing is super useful if you have multiple different heights for a scan. I'll show you that once this full rotation finishes. So yeah, you want to make sure that you get a full rotation because otherwise you'll be missing parts of your scan. But as you can see, we're almost there. And then there we go. So now we've overlapped, and that's good enough. You don't need to do more overlaps because once you do one full rotation, that's as good as it gets. So now that we've done one full rotation, we can actually click pause and admire how our scan looks. So let's take a look. This guy is missing, a little bit at his chin. So actually, we're going to need to move the scanner down and then continue the scan. So let's do that. I'm going to move the scanner down. Note that I'm still paused right now. I'm going to move the scanner down, and I'm going to point it upwards to see if I can get his face. Now notice, I want to make sure that I still get the red dots in this camera, because those markers are what it's going to use to calculate how to basically scan this guy. So we want to make sure that we still have the markers, which is good. We want to get to the middle of the crosshair. Make sure to put it in the center of the turntable. Mine's a little offset, but still going to work. And then let's click start to continue. So let's see. We're getting a warning that we need more markers. So we're going to raise it up a little bit and then show more markers. So hopefully this will help connect the object scan. So yeah, now we're getting a different altitude scan. This is useful for trying to cover those details. To get this detail though, I would honestly probably have to prop the turntable up using a box and switch the scan mode from marker to feature, because then I wouldn't be able to see any of the dots. Anyways, our scan is going. You can see there's some extraneous dots, but we'll be able to get rid of that in post. So we're just gonna let him scan for a bit. You can see the amount of frames is increasing, but overall the scan is going good. Alright, so once we're done with that rotation, I think we're good. So we're going to click pause for a second. You notice the model is a little bit dirty from that time where we didn't have any tracking, but we should be able to fix that. So let's click complete, and then there we go. Our scan is now in. So this is the point cloud that we captured. Point cloud just refers to all the points that the 3D scanner scanned. So you can see we have small holes, those are fixable, and you can see that, the points are a little bit jumbled up. But all that is definitely fixable. So yeah, now that we have our scan, that's where the top bar of the software comes in. This is how we're going to fix our model. So first off, you can click one click. One click will basically process your entire model. However, those settings it picks might not be super good. So I'm going to show you what each of these buttons does, or at least give you a brief description, and then we're going to work through them. The good thing is that basically you start from the left and then work your way down to get your full model. So we're going to start here at Fusion. Fusion, there's little descriptions here, but it basically combines your points, kind of averages them out to get a better model. So, we'll just start. I like the default settings. The default settings work pretty well. Alright, so now that our model is generated, you can see that it looks a lot better. But there's still, some floating objects here and there. But it looks at least, kind of like the guy. So this is what isolation is for. Isolation is going to select everything under 15% of the total amount of points and then highlight it. So everything that's, not connected to the main model is going to get selected. So there's some floating stuff here. There's some stuff that's inside. All that was selected. If stuff doesn't get selected, you need to adjust your isolation rate so that everything that's bad gets selected. Now, notice one important thing is that pretend we had the box in the scan and the box was bigger than our model. There's no way to select individually what to delete. So if you have trash in your scan that's actually bigger than the original model, then actually you won't be able to scan. So you won't be able to get rid of the islands. So make sure to keep that in mind when you set up your point clouds. Anyways, I'm going to click apply, and then there we go. It should remove everything. So we have a little bumps down here. We got a little hole there, but you can see it looks a lot better. So now we're going to go to the overlap. This is going to detect points that are intersecting with other points. So I'm just going to click that, and look, our model is actually so good we don't have any overlap. Again, default settings works fine. Smooth is a good tool because smooth will basically average out points so that you get a smoother object. So if you have a very bumpy object, it might be, the thing with smooth is that if you have a super bumpy object, the scanner is pretty good. So if you have a super bumpy object and you make the strength of the smooth too powerful, you'll actually make your model quality worse because then it won't actually look bumpy. So I like to, decrease the smooth strength. I mean, honestly, these points look pretty good. I just want to change up a little bit. However, it doesn't change that much, so it's okay. Finally, simplify. This is just like smooth, where it's going to remove more dots. The more dots you have, the bigger your file is going to be. Big files might take long times to slice on 3D printers. So if you want to simplify, you can always use the simplify button. I'm going to set it to low ratio because I kind of want high fidelity. But you can see that it kind of simplified parts of him. Parts where it was kind of smooth. Now, if you don't like that change, and I honestly am not a big fan of that change, you can Control Z and he'll revert just back. You can actually see that the project is here, right here, so you can actually do a lot of things from the project here. And if you scan something else, it will show up under this project. So each time you make a scan, it will show up down here. Okay, now we're ready to make a mesh. So mesh converts all these points into an object that you can 3D print. There's a lot of settings here. You could mess with them, but let's just try to get through this and get a cool model. So there we go. That looks a lot better. This is our 3D model of our guy, and that looks honestly pretty detailed. So let's continue. Isolation, this is the same thing, but instead of looking at points, it looks for vertices or faces that are open. So let's try to detect any. Nope, nothing found. That's good. Fill holes, this is the most important. So there's a plane method and a curved method. It kind of depends which one, but when you run it, it's going to highlight every hole on your guy in green. So what you're going to do is you're going to select these holes to turn red. So every hole you want to close, select the hole. I want to make a full 3D printed model of this guy, so I actually want to select all the holes. So now, when I click apply, they get filled in. Obviously, there was no scanning color where there were holes, so the color is just an average of the color all around. For a uniform object like this, it's fine, but if you have a hole where there's like important color or like a text, then obviously it's going to be filled in with random garbage. The smooth tool for meshes is super powerful, which means that if you run this at very high strengths, it will make your model much smoother. So I honestly don't really mess with this one unless I need to use my model in a game or a computer that doesn't have a lot of power, because I really want my models to be high quality. Also, I noticed I have a hole up here, so we're going to actually have to fill the hole again. There we go. Apply. And now the holes are filled. To cover that hole, I should have moved the 3D scanner a little bit higher. Alright, now that we're here, we can finally texture the model. Yes, you can simplify and smooth it, but I really want high quality. So I want to create a texture. For this guy, it's not going to change much because, he's one color. But for things like an expo marker or other things, you really need to use this texture button. So to make the texture, we're going to click this, and it's going to process all your images. the bigger your model is, the more complicated it will be. So yeah, let's run it and see what happens. All right, the texturing is complete. So you can see we kind of got the grain from, the images, but now you have a texture that you can actually print. So now you can see that we have the shadows from, the lights in the ceiling. So we have all this cool texture, and now we have a great model that you can use in a game or something. There's a merge button. I don't really use this, but you can combine two models together with it. I just want to use export because I want, to print this. So here's what this does. For export, first you can export all models, but there's also other options. You can export just the point cloud. So if you ever, let's say you make your model super smooth, but you want to make a version that's super high quality as well, you can export the point cloud and then reopen it in Revo Scan. Then you can, go through all these settings again and then try it for like a different type of quality. The mesh model and the texture model are the most important and the ones you actually probably want. So the mesh model is going to have just the vertices. This can be an ply, an obj, or an STL. The STL is the one you want for 3D printing. So if I want to 3D print the guy, I want an STL. So I can do 3D print guy. Just pretend like it's saved. But anyways, that's how you can get a 3D printed model of the guy. However, if you want a different type of model of the guy, and you want to, let's say put it in a game, or use a full color 3D printer, you can use a texture model. This will produce a model that has full textures. So this is very useful if you want to have your guy in a game, an animation, or on a full color 3D printer. You can pick between ply and obj for this. I prefer obj because it's more universally accepted. And on the Aero Makerspace full color 3D printer, you're going to have to use the obj format. Overall, that's how you export it. We basically scanned this guy. Now you just want to make sure to put everything back. You can see how we went from the point cloud, we made a better point cloud, we meshed them up, and we added a texture. So there you go. We have made a full 3D scanned object in, a quick amount of time. Overall, that is how to use the Aero Makerspace Pop 3 3D scanner. So as you can see, we started with this bust, we used the 3D scanner, and we used the Revo Scan software to make the final 3D model. Thank you for watching.